Hi, welcome back to our channel Neet Kumar Basics of Physics. Dear aspirants and viewers, in this video we are going to discuss about the how we can write the dimensional formula. First thing, what is mean by dimensional formula and what is dimension and what is dimensional equation, and how we can write the dimensional formula of different physical quantities, for which quantities they have dimensions are 0, and in heat how we can write the dimensional formulas, for current physical quantities how we can write the dimensional formulas, and which type of questions are going to be asked in competitive exams. Some model questions will be discussed in this video, and the physical quantities which are having the same dimensional formulas. So we will discuss these things in this video very clearly and in detail. Clear? What is mean by dimensional formula? The expression which can gives the dimensions of physical quantities in terms of base quantities, that should be called dimensional formula. And in a dimensional formula, the numbers what we are writing as exponents of base quantities, they can be called dimensions. The numbers which we can write as powers of physical quantities, they can be called as dimensions. And what is mean by a dimensional equation? A physical quantity symbol and its dimensional formula should be written in form of a equation, then that should be called as dimensional equation. So these are the basic things you have to have idea about these things. What is dimensional formula, what is dimension, and what is dimensional equation. So some definitions are on board, it is there, you have to observe here. The expression which shows how and which of the base quantities represent the dimensions of physical quantity is called dimensional formula. The expression which shows how and which, a expression aithe which shows em chupistundanda which of the base quantities represents the dimensions of physical quantity. ఒక ఫిజికల్ క్వాంటిటీ అనేది బేస్ క్వాంటిటీస్ని ఉపయోగించి దాని యొక్క డైమెన్షన్ చూపిస్తూ రాస్తే దాని డైమెన్షన్ ఫార్ములా అంటాము. దాని యొక్క ఎగ్జాంపుల్ ఇస్తే మీకు క్లియర్ అర్థమవుతుంది. లెట్స్ వెయిట్. అండ్ డైమెన్షన్స్ డెఫినేషన్ చూడండి. When a derived quantity is expressed in terms of fundamental quantity, it is written as a product of different powers of the fundamental quantities. The powers to which the fundamental quantities must be raised in order to express the given physical quantity are called dimensions. When a derived quantity is expressed, ఏదైనా ఒక derived quantityని మనం expressed in terms of fundamental quantities లేదా base quantities లో రిప్రజెంట్ చేసేటప్పుడు is written as a product of different powers of fundamental quantities. Different fundamental quantities యొక్క పవర్స్ తో మల్టిప్లికేషన్ లాగా రాస్తే, ప్రోడక్ట్ లాగా రాస్తే, the powers to which the fundamental quantities must be raised in order to express the given physical quantity are called dimensions. So సింపుల్గా మనం ఏదైతే పవర్స్ రాస్తామో డైమెన్షన్ అంటాం. Look here, next one. An equation obtained by equating the physical quantity with its dimensional formula is called dimensional equation of the physical quantity. An equation, ఏ ఈక్వేషన్లో అయితే మనము by equating the physical quantity with its dimensional formula, ఒక ఫిజికల్ క్వాంటిటీని దాని యొక్క డైమెన్షన్ ఫార్ములాతో ఈక్వల్ చేస్తే దాన్ని మనం డైమెన్షనల్ ఈక్వేషన్ అంటాము. సో ఫర్ ఎగ్జాంపుల్ ఇప్పుడు చూడండి జాగ్రత్తగా, ఇక్కడ వెలాసిటీ అంటున్నాం. వెలాసిటీ ఈజ్ ఈక్వల్స్ వాట్? డిస్ప్లేస్మెంట్ బై టైం. డిస్ప్లేస్మెంట్ బై టైం. సో డిస్ప్లేస్మెంట్ డైమెన్షన్ ఫార్ములా ఈజ్ ఎల్ and time capital T. Then what we write here? L T inverse 1. L T inverse 1, and it can also express like this: m to the power of 0 L T to the power of minus 1. ఇక్కడ మాస్ అనేది లేదు కాబట్టి we can write m to the power of 0, length L and T inverse 1. So in that one, m to the power of 0, here what is dimension here? డైమెన్షన్ ఆఫ్ మాస్ ఈజ్ 0. అంటే ఇక్కడ ఏవైతే మనం ఏం రాస్తున్నామో అదొక ఫండమెంటల్ క్వాంటిటీని చూపిస్తుంది. ఆ ఫండమెంటల్ క్వాంటిటీ ఏంటి? మాస్. ఆ మాస్ పవర్ పైన ఎంత ఉంది? 0 ఉంది. సో కాబట్టి డైమెన్షన్ ఆఫ్ మాస్ ఈజ్ 0. అట్లనే డైమెన్షన్ ఆఫ్ లెంత్, డైమెన్షన్ ఆఫ్ length. Now here what do you write here? L to power of 1 is there, nothing is there means what? L to power of 1 is there. That's why here dimension of length is 1. L to power of మనం 1 అని రాదు, ఇక్కడ ఏం లేకపోయినా 1 అని ఉంటుంది కాబట్టి డైమెన్షన్ ఏమవుతుంది? 1 అవుతుంది. అట్ ద సేమ్ టైం ఇక్కడ డైమెన్షన్ ఆఫ్ t అంటే ఏంటి? టైం ఎంత ఉంది? -1 ఉంది, -1. సో అంటే మనము ఏవైతే ఒక ఎల్ లెంత్ ఫండమెంటల్ క్వాంటిటీ, టీ టైం ఫండమెంటల్ క్వాంటిటీ, వాటిపైన పవర్స్ రాస్తున్నాం. సో దిస్ ఎల్ టు పవర్ ఆఫ్ 1, టీ టు పవర్ ఆఫ్ -1. సో ఇలా రాసినప్పుడు దీన్ని ఏమంటామంటే డైమెన్షనల్ ఫార్ములా అంటాం. నౌ ఎల్ టీ ఇన్వర్స్ 1 ఆర్ ఎం టు పవర్ ఆఫ్ 0 ఎల్ టీ ఇన్వర్స్ 1, ఎల్ టీ ఇన్వర్స్ 1. ఇట్ ఈస్ ద డైమెన్షనల్ ఫార్ములా ఆఫ్ వెలాసిటీ, dimension formula of velocity. And these 0, 1, -1 what we call? These are the dimensions. What they are? They are the dimensions. Now what about the dimensional equation? Dimensional equation. So simply here the same thing we are going to write like this. We are writing now V is equals to L to the power of -1. Now it is the dimensional equation. Dimensional equation. V is the velocity, it is a physical quantity, and that should be equal to what? It's a dimensional formula. That's why it is what you call dimensional equation. And a physical quantity ni దాని యొక్క డైమెన్షన్ ఫార్ములాతో మనం ఈక్వల్ సింబల్ పెట్టి రాస్తే దాని డైమెన్షనల్ ఈక్వేషన్ అని అంటాము. సో ఇప్పుడు వీటి ఆధారంగా డైమెన్షనల్ ఫార్ములా ఆధారంగా హౌ వీ కెన్ రైట్ ది units. Simply here L is what? Length, but its unit is what? Meter. And T is what? Time. So meter second inverse 1. So for length unit is the meter and time second. So second inverse 1. Power 1 -1 కాబట్టి we can add -1. So meter second inverse is unit of velocity and it is also written as meter per second. So this is about simply what is dimension formula and what is dimension and what is dimension equation and how we can write the units. Okay, now we can go for different dimensional formulas for different physical quantities. How we can write? Let's see. To write any dimension formula you have to remember how the fundamental quantities or base quantities can be represented as dimensional formula. డైమెన్షన్ ఫార్ములా రాయాలి అంటే ఖచ్చితంగా మనకి ఫండమెంటల్ క్వాంటిటీస్ని యొక్క డైమెన్షన్ ఫార్ములా ఎలా ఉంటాయి అని తెలియాలి. ఫర్ మాస్ క్యాపిటల్ ఎం, ఫర్ మాస్ క్యాపిటల్ ఎం. సో లుక్ హియర్, ఫర్ మాస్ హియర్ we can write like this. This is the dimension formula of mass. Similarly, dimension formula of length is like this. Capital letters you have to use. Okay. And next similarly time, capital T. And similarly here temperature, that should be given like this, K or theta. So you can use any one of these two, K or theta. And current, A or I, A or I. So these are the dimension formulas of base quantities you have to remember. మనకి ఎగ్జామ్ పాయింట్ ఆఫ్ వ్యూలో ఎక్కువ అడుగుతున్నటువంటిది మాస్, లెంత్, టైము, టెంపరేచర్, కరెంట్ కాంబినేషన్ తప్ప మిగతా ఎక్కువ యూస్ చేయడు. సో కాబట్టి ఫస్ట్ ఇది తెలిస్తే మనకి వీ హ్యావ్ టు రైట్ ది డైమెన్షన్ ఫార్ములా ఆఫ్ డిఫరెంట్ ఫిజికల్ క్వాంటిటీస్. సో టు రైట్ ఎనీ dimension formula of any quantity, first we have to have idea about what is the formula for that particular physical quantity. Is there any formula? మనకి ఒక ఫిజికల్ క్వాంటిటీ యొక్క డైమెన్షన్ ఫార్ములా రాయాలి అంటే ఫస్ట్ మనకు తెలియాల్సిన విషయం ఏంటి, ఆ ఫిజికల్ క్వాంటిటీస్ని ఎలా డైమెన్షన్ ఫార్ములా చూపిస్తారో తెలియాలి. అంటే ఫండమెంటల్ క్వాంటిటీస్ ఏవైతే మనం యూజ్ చేస్తున్నామో వాటి యొక్క డైమెన్షన్ ఫార్ములా తెలియాలి. సో రెండో విషయం ఏంటంటే మనకి ఆ ఫిజికల్ క్వాంటిటీ యొక్క ఫార్ములా తెలిస్తేనే మనం డైమెన్షన్ ఫార్ములాని రాయగలుగుతాము. So I will give some examples. So look here, the first thing is area. So what is the area? We can write length into breadth, length into breadth. So it is the formula. So simply I am going to, this is the formula. Okay, formula, what is length into breadth? So length into breadth. So length is nothing but S, capital L, and breadth also measured in terms of S by using the base quantity L. Length ni మనం capital L అంటాం, breadth కూడా L అంటాం. సో అప్పుడు ఏమవుతుంది, L to power of 1 plus 1. When bases are equal, we have to add the exponents. Now what it is? It is L square. What is L square? L square is the dimension formula of area. So దాన్ని మనం ఎలా రాసుకోవచ్చు, m to power of 0, L square and t to power of 0 you can write. Clear? So the same thing we are going to express here. Dimension formula is in terms of m to power of 0, L square and t to power of 0. So in this one, the dimension of mass is what? 0. Dimension of L is what? 2. Dimension of t is what? 0. Clear? So that is the dimension formula of area. And now here m to power of 0 is there, nothing but it is 1. So 1 is nothing but constant. For that constant there is no unit. m to power of 0 అంటే 1, దానికి ఎటువంటి నెంబర్ కాబట్టి యూనిట్స్ ఉండవు. t to power of 0 also 1. సో దేనికి ఉంటుంది కానీ లెంత్కే ఉంటుంది కాబట్టి ఫర్ లెంత్ వాట్ ఇట్ ఈస్, మీటర్ ఈస్ ద యూనిట్. దట్స్ వాట్ ఇట్ హియర్, మీటర్ స్క్వేర్. మీటర్ స్క్వేర్ ఈస్ ద యూనిట్ ఫర్ ఏరియా. And similarly volume, length in formula is what? Length into breadth into height. Length into breadth into height. So already length we can take in fundamental quantities, length here L, again L, height also L. So then what, right? L to power of 1 plus 1 plus 1, L cube. That means m to power of 0, L cube and t to power of 0. Then the units are what? Meter cube. Meter cube. Clear? And now mass for mass density. Mass density. The formula is mass for volume. Mass for volume. So already for mass, what it is, the dimension formula capital M by volume. Volume means what? L cube. Clear? What right here? M L cube. పైకి వస్తే అవుతుంది L to power of -3 అవుతుంది. L to power of -3 అవుతుంది. So and there is no t, that's what right, t to power of 0. So m L inverse 3, t to power of 0. So you can observe now these three. Among these three, what you can understand, the dimensions may be either is positive or negative. మనము ఏవైతే బేస్ క్వాంటిటీ తీసుకున్నామో ఆ బేస్ క్వాంటిటీ యొక్క డైమెన్షన్స్ అనేవి 0 అయి ఉండొచ్చు, నెగిటివ్ అయి ఉండొచ్చు, పాజిటివ్ అయినా అయి ఉండొచ్చు. సో కాబట్టి ఇక్కడ దిస్ ఇస్ వాట్ మాస్. మాస్ యూనిట్ ఇస్ వాట్? కేజీ. అండ్ ఎల్ ఈజ్ వాట్? లెంత్. మీటర్ ఇన్వర్స్ 3. మీటర్ ఇన్వర్స్ 3. సో దాన్ని మనం సింపుల్ ఎలా రాస్తామంటే కేజీ ఫర్ మీటర్ క్యూబ్ వీ కెన్ రైట్. దట్ ఈస్ ద యూనిట్ ఆఫ్ డెన్సిటీ. And similarly frequency, what is frequency? The number of vibrations made per second. Simply here what write? 1 by time we can write. 1 by time we can write. Frequency is what? 1 by time. So then obviously what write here? 1 by t. That means what? T inverse 1. T inverse 1. And మళ్ళీ ఏం రాసుకోవచ్చు? m to power of 0, L to power of 0, t to power of -1. ఇది రాస్తే కరెక్టే, ఇదన్నా కరెక్టే. ఆప్షన్స్ మనం చెక్ చేసుకోవాలి జాగ్రత్తగా. సో t to power of -1 అంటున్నాం అంటే ఏమవుతుంది? సెకండ్ ఇన్వర్స్. యాజ్ ఫర్ డైమెన్షన్ ఫార్ములా ఇట్స్ యూనిట్ ఇస్ వాట్? సెకండ్ ఇన్వర్స్. సో దీన్నే మనము ఏమంటామంటే హెడ్జ్ అంటాం. వాట్ యు కాల్? హెడ్జ్ ఆర్ వైబ్రేషన్స్ ఫర్ సెకండ్. వైబ్రేషన్స్ ఫర్ సెకండ్. ఇవన్నీ కూడా యూనిట్స్ ఆఫ్ ఫ్రీక్వెన్సీ. అండ్ నౌ వెలాసిటీ అంటే మనం డిస్కస్ చేసాం. డిస్ప్లేస్మెంట్ బై time. Displacement L, time T, that is what? LT inverse 1. So according to that what right? Meter second inverse 1 or meter per second we can write. So the address goes to m to power of 0, L, t to power of -1 also we can write, no problem. And now acceleration. Acceleration means what? change in velocity by time, change in velocity by time, change in velocity by time. Simply I am going to write velocity for time, velocity for time. Already what is velocity here? LT inverse 1 by again time t. That means what? L t to the power of minus 1 multiply minus 1 avutundi, minus 1 minus 1, that is what? LT inverse 2, LT inverse 2. That is the dimension formula of acceleration. Then మనం కూడా రాసుకోవచ్చు m to the power of 0 L t inverse కూడా రాసుకోవచ్చు. Clear? అప్పుడు దాని యూనిట్స్ ఏమవుతాయి? As for this one, for mass it is 0, that's why there is no kg in units L, meter and second inverse 2. దీని మనం ఏం రాస్తాం? మీటర్ ఫర్ సెకండ్ స్క్వేర్ రాస్తాం. Clear? Now force. What is the dimension formula of force? F is equals to ma. F is equals to what? ma. m అంటే ఏంటి? మాస్, క్యాపిటల్ M. ఏ అంటే మనం యాక్సలేషన్ ఇంతకుముందు వచ్చింది LT inverse 2. So m L t inverse 2. So that is the dimension formula of force. So as for this what right here, for mass unit is kg, length meter and time second inverse 2. kg meter second inverse 2. So as a unit se raskochu now already similar to what? kg meter second inverse 2 is also called as Newton. Impulse, I is equals to F into T. I is equals to F into T. F is what? Force. T is what? Time. So force ఏంటి? M L T inverse 2 into time T. So then what right here? M L T inverse 1. M L T inverse 1 is the dimension formula of what? Impulse. And its unit is what? kg meter second inverse 1. Clear? And now here work. W is equals to F into S. F into S. Then F is what? M L T inverse 2. And S is what? Displacement, nothing but length. What we write here? L. Then what you get here? M L square T inverse 2. So and units are now what it is? Mass, kg. L square means what? Meter square. And T inverse 2 means what? Second inverse 2. And it is taken as joule. And similarly here kinetic energy of m v square formula is what? Kinetic energy is equals to half mv square. Half is a number. For number there is no dimension formula. Mass, capital M. And what is v? Velocity. What do you have velocity? LT inverse. What is velocity? LT inverse 1. LT inverse 1. So LT inverse 1 whole square. Velocity what? LT inverse 1 whole square here. Then what you get here? M L square T inverse 2. M L square T inverse 2. So that is the dimension formula of kinetic energy. Same here we have work, kinetic energy also having same dimension formulas and same units. Clear? So in this way we will write the differential dimension formula for any physical quantity, and based on that we can write the units of the physical quantity. Let's see some other dimension formulas for different physical quantities. ఇంకొన్ని చూద్దాం. Okay, look here. First thing is momentum. Momentum formula is mass into velocity. Mass into velocity. So mass dimension formula is what? Capital M. And for velocity LT inverse 1 మనం డిస్కస్ చేసాం ఇంతకుముందే. సో అప్పుడు డైమెన్షన్ ఫార్ములా అవుతుంది M L T inverse 1. So this is the moment and dimension formula. As for dimension formula unit is what? For mass kg and length meter, and it is second inverse 1. Kg meter second inverse 1, and it is also written as kg meter per second we can write. Clear? Next, pressure and stress. For both same dimension formula, pressure and stress. Formula is force per area. Force per area. Already we discussed for force M L T inverse 2 is the dimension formula. For area L square. Clear? Then what is we can write M L L to the power of minus 2 T to the power of minus 2. L to the power of 1 and minus 2. Then what right here? M L to power of minus 1 T inverse 2. This is the dimension formula of pressure or stress. So M L inverse 1 T inverse 2. And as for dimension formula, units are what? Kg, meter inverse 1 and second inverse 2. Clear? And it is also called as here Pascal. What is Pascal? And another unit is there, Newton for meter square. Newton for meter square. As for this formula, unit is Newton for meter square. So these are the units of pressure and stress. Kg, meter inverse, second inverse 2. Okay now. And next, strain. This is the one important one. Strain is nothing but here change in dimension. Change in dimension by original dimension. Original dimension. For example, one rod it is there that should be having some length 20 centimeters. ఒక రాడ్ ఉంది, దాని లెంత్ 20 సెంటీమీటర్స్. మనం హీట్ చేసాం, అప్పుడు దాని లెంత్ ఏమైందంటే 22 సెంటీమీటర్స్ అయింది. 22 సెంటీమీటర్స్ అయింది. ఎంత చేంజ్ అయింది? 22 minus 20, that is what? 2 centimeters. 2 centimeters by here what we are reading? Change in dimension. Here dimension is what? Length. Change in length by original length. So what is here? 2 centimeter by original length is what? 20 centimeters, like that. So కాబట్టి ఇక్కడ చేంజ్ ఇన్ డైమెన్షన్ బై ఒరిజినల్ డైమెన్షన్ అన్నప్పుడు మనము ఇక్కడ లెంత్ తీసుకున్నాం కాబట్టి చేంజ్ ఇన్ డైమెన్షన్ ఇస్ ఆల్సో లెంత్ అండ్ ఒరిజినల్ డైమెన్షన్ ఇస్ వాట్? లెంత్. సో సేమ్ ఫిజికల్ క్వాంటిటీ కాబట్టి L by L we can write, then L to power of 0. Clear? That's why here we can write M to power of 0, L to power of 0 and T to power of 0. So you have to remember strain is the dimensionless quantity. Dimensionless quantity, and there are no units for what? Strain. ఎందుకంటే చూడండి 22 centimeters by 20 centimeters, centimeter cancel అవుతుంది కదా. So like that there is no units for strain. And modulus of elasticity. Modulus of elasticity formula is stress by strain. Stress by strain. So what is stress here? Dimension formula is what? Stress, this we discussed. M L inverse 1 and T inverse 2 by strain. There is no dimension formulas. M to power of 0, L to power of 0, T to power of 0. That means what? Again we will get same thing. M L inverse 1, T inverse 2. Clear? So kabatti that is also having same units of pressure. And now here Newton for meter square. Look here now. So next one is surface tension. Surface tension formula ఏంటంటే force per length. What it is? Force per length. Force dimension formula is what? M L T inverse 2 by L. So L cancel. What you get? M to power of M, L to power of 0, T inverse 2. T inverse 2. Clear? So surface tension formula is what? M L to power of 0, T to power of minus 2. మనం ఏవైతే పవర్స్ రాస్తున్నాం అంటే ఏమన్నాం? డైమెన్షన్స్ అన్నాం, దాన్ని మర్చిపోకండి. సో లుక్ హియర్ నౌ kg second inverse 2, kg second inverse 2, and it is also mentioned like this, Newton for meter. Newton for meter because as for this one force Newton, length meter. And now angle theta. Angle and angular displacement both are similar here. What do you write? Arc by radius. Arc by radius is the formula for angle. Then arc and radius both are having length. That is also here M to power of 0, L to power of 0, T to power of 0. So for angle there is no dimensions. So there is no dimension formula for angle. So this is also you have to remember. But units are there. These are radians. What it is? Radians. Difference between strain and angle is what? For strain there is no dimension formula, no units. But in case of angle there is no dimension formula but unit is there. అర్థమవుతుందా? స్ట్రెయిన్ వచ్చేసరికి మనకి ఇక్కడ డైమెన్షన్స్ 0 ఉన్నాయి, యూనిట్స్ ఏం లేవు. కానీ యాంగిల్ వచ్చేసరికి మన డైమెన్షన్ ఫార్ములా లేదు కానీ యూనిట్స్ అయితే ఉన్నాయి, రేడియన్స్. అట్లనే సైన్ తీటా, కాస్ తీటా, టాన్ తీటా ఇలాంటి ట్రిగ్నామెట్రీ రేషియో వచ్చినప్పుడు ఫర్ రేడియస్ దట్ ఈస్ ఆల్సో హ్యావ్ యూ కెన్ రైట్ length by length, length by length. So for trigonometric ratio, formula is what? Length by length, and it is also dimensionless quantity, and units are here radians. And now angular velocity, angular velocity, angular velocity. So here, that is the angular displacement by time. Formula is what? Angular displacement by time, angular displacement by time. That means what? Angular displacement is, there is no dimension formula, by time, 1 by t. That is what here? T inverse 1, T inverse 1. So it is quite similar to the frequency, dimension formula of frequency. Clear? Now it is what? Radian per second. Radian per second is the unit for angular velocity. Clear? And now children, potential energy. Potential energy formula is here mgh. For mass, capital M. For g, s, acceleration due to gravity. For height, L. Then what we read here? M L square T inverse 2. L square T inverse 2. And units are again joule or kg, meter square or second inverse 2. So these are the dimensions formula of some other quantities. Okay. So see some other dimension formula of physical quantities. So these are some constants are there. Watch very carefully. The first thing is Planck's constant, and its formula is E is equals to h nu. From that what write? H is equals to E by nu we can write. What is E? Energy. Energy dimension formula is what? M L square T inverse 2 is the dimension formula of energy. And the frequency is what? T inverse 1. Then what you can write? M L square and T to the power of minus 1, and this is 1. Then what write here? M L square T to the power of minus 1. So this is the dimension formula of Planck's constant. Clear? So then what write here? Kg meter square second inverse 1. Kg meter square second inverse 1. So it is also written as what it is? Joule second inverse, or joule for second inverse, or joule second. So what is the unit of energy? Joule. And here nu means what? Frequency, second inverse, or joule second. Joule second we can write. And next, this is the most important one. We have some specialty is there. Gravitational constant. Formula is F is equals to G m1 m2 by r square. From that formula we can write G is equals to F into r square by m1 m2. Here F is the force, r is the distance, and m1 m2 are the masses. So now what I had here for force? Force dimension formula is what? M L T inverse 2 and r square L square by m1 m2 masses m. So here what right? M is there already here, m to the power of minus 2 is there now, and L square L cube and T inverse 2. Clear? So m to the power of 1 and m to the power of minus 2, that means what? M inverse 1, m to the power of minus 1, L cube and T inverse 2. So the specialty of this one is the dimension of mass is here negative. Clear? Gravitational constant యొక్క డైమెన్షన్ ఫార్ములాలో మాస్ యొక్క డైమెన్షన్ నెగిటివ్ ఉంటుంది చూడండి, -1. మనం ఇంతకుముందు చూసిన డైమెన్షన్ ఫార్ములాస్లో ఎక్కడ నెగిటివ్ రాలేదు, బట్ ఇక్కడ నెగిటివ్ వస్తుంది, చూసుకుని జాగ్రత్త. సో యాజ్ ఫర్ దిస్ ఫార్ములా వాట్ రైట్? డైమెన్షన్ ఫార్ములా కేజీ ఇన్వర్స్ మీటర్ క్యూబ్ సెకండ్ ఇన్వర్స్ 2. అండ్ యాజ్ ఫర్ దిస్ వన్ what right? Force Newton, distance meter square by kg square. And now coefficient of viscosity, the formula is Neet is equals to F by A by delta V by delta X. Here delta V by delta X is the velocity gradient, what we call velocity gradient. Velocity gradient. That is what? Delta V by delta X. Delta V means what? Change in velocity. That is what? LT inverse 1 by delta X, length L. LL cancel. We get T to the minus 1. So that is nothing but frequency dimension formula. Clear? And already we discussed F by A. What is F? Force. M L T inverse 2 by L square. Then what you get? M L inverse 1 T inverse 2. So substitute now here. F by A means what? M L inverse 1 and T inverse 2 by velocity gradient T inverse 1. Then what you get here? M L inverse 1 T inverse 2 and T to the power of 1. Then what you get? M L to the power of minus 1 T to the power of minus 1. So that is the dimension formula of coefficient of viscosity. Coefficient of viscosity. As for this dimension formula, we can write Kg meter inverse second inverse. Second inverse. So now F by A. What is? Pressure. Newton for meter square. Newton for meter square. Delta V by delta X. Delta V by delta X. Meter per second by meter. Meter cancel. Second inverse. Second inverse. And it is what? Newton for meter square. So Newton meter square into second we get dimension units of the coefficient of viscosity. So అదైనా రాసుకోవచ్చు, అదైనా ఉంచండి సరిపోతుంది. నెక్స్ట్ సో దీని ప్రకారం అయితే న్యూటన్ ఫర్ మీటర్ స్క్వేర్ ఫర్ సెకండ్ ఇన్వర్స్ అవుతుంది. ఓకేనా. నెక్స్ట్ టార్క్ ఫార్ములా ఈస్ టౌ ఈజ్ ఈక్వల్స్ టు ఆర్ క్రాస్ ఎఫ్. ఆర్ క్రాస్ ఎఫ్. సో ఎఫ్ అంటే ఏంటి? ఫోర్స్. ఎంఎల్ టీ ఇన్వర్స్ 2 ఇంటూ ఆర్ మీన్స్ వాట్? డిస్టెన్స్ ఎల్. దెన్ వాట్ ఆర్ హియర్? L square. L square T inverse 2. That is the dimension formula of torque. It is nothing but it is same as the energy and work. Clear? So here now again as for this one kg meter square second inverse 2. And as for this what right here? Newton meter. Force is Newton and for distance meter. And now moment of inertia formula is I into mr square. I is equals to mr square. M is what? Mass and r is what? Distance. Clear? So then what is ml square? ml square or ml square t inverse t to the power of 0. So now units are what? Kg meter square. Kg meter square. Now angular momentum. So formula is L is equals to mvr. What did here? For mass capital M, velocity LT inverse 1 and R means distance. That is what? ml square T inverse 1. ml square T inverse 1. So units are kg meter square second inverse 1. Clear? కరెంట్ చాప్టర్లో వచ్చేటువంటి కొన్ని ఇంపార్టెంట్ డైమెన్షన్ ఫార్ములా చూద్దాం. లెట్ us see some dimension formula of physical quantities which are coming in the chapters of electricity. So first thing is charge. So charge dimension formula is what? Here what we know, current I is equals to Q by T. This is the formula. From that what I Q is equals to I into T. I is the current, Q is the charge, T is the time. Clear? So already we know that what is current can be shown? Current should be shown like this, A, and time T. So therefore here what is dimension formula of charge? A into T, or simply we can write m to the power of 0, L to the power of 0 and T A. That is the dimension formula of charge. So units are now here coulomb. What is coulomb? And now potential V is equals to what? W by Q we can write. Potential V is equals to W by Q. W is what? Work. Q is what? Charge. So M L square T inverse 2 is the dimension formula of work by charge T A. Then what do you get here? M L square T inverse 2 and it is comes to numerator T inverse 3 and A inverse 1. Clear? And potential unit is what here? Simply what you can write? W by Q. V means volt. What you can write? Volt. R you can write joule for coulomb. Joule for coulomb you can write. Coulomb is the charge unit. Okay. Now intensity of electric field. E is equals to F by Q. E is equals to F by Q formula. Again F is what? Force. M L T inverse 2 by again T into A. TA is the dimension formula of charge. Then what read here? M L T inverse 3 A inverse 1. So that is the dimension formula of intensity of electric field. Intensity of electric field we can write Newton for Coulomb. Newton for Coulomb. Again as usual we can write here kg meter second inverse 3 amperes inverse 1. That is also here unit. And capacitance C is equals to Q by V. C is equals to Q by V is the formula. Here what is Q? Charge, and what is V? Potential. Already what we know, Q is what? Charge. Its dimension formula is what? A T by potential. What is the potential dimension formula? M L square T inverse 3 A inverse 1. Clear? C is equals to Q by V. So if I this को दबड़े होती M inverse 1 L square and T to the power of 4 and A to the power of 1 and A square. So this is the dimension formula of capacitance. M inverse 1 L to the power of minus 2. Sorry, L to the power of minus 2. M inverse 1 and L to the power of minus 2, T to the power of 4 and A square. So its units are farad. So that should be shown like capital F. V is equals to IR. Ohm's law. V is equals to IR, and R is equals to what? V by I. R is equals to what? V by I. So what is V? Potential. M L square T inverse 3 A inverse 1. This is the dimension formula of potential by current. A. I already told you, sometimes in some books will be these like A R I. No problem at all. Then what is here? M L square T inverse 3 and A inverse 2. This is the dimension formula of resistance. So resistance unit is what? Ohm. Symbol is what here? So we can write ohm. And conductance. So conductance is nothing but reciprocal of resistance. Reciprocal of resistance. So that means what here? 1 by M L square T inverse 3 A inverse 2. That means what? M inverse 1 L to the power of minus 2 T cube and A to the power of 2. This is the dimension formula of conductance. So units are mho. Ohm ki reverse mho is the unit of conductance. See the next one. Resistivity. Resistivity formula is like this. R is equals to rho into L by A. This is the formula for resistance. From that what right here, rho is equals to RA by L. Rho is equals to RA by L. What is R? Resistance. What is A? Area. What is L? Length. So already we discussed about the dimension formula of R. What it is? Already it is there. M L square T inverse 3 A inverse 2 by length and area L square. Clear? Then what you get here? M L square L to the power of 4 and minus 1 L cube M L cube T inverse 3 A inverse 2. That is the dimension formula of resistivity. M L cube T inverse 3 A inverse 2. And units are now here ohm meter. Ohm meter. Clear? Ohm meter is the unit for resistance. And now resistivity. Here next thing is conductivity. Conductivity, nothing but it is reciprocal of resistivity. That means what? 1 by m L cube T inverse 3 A inverse 2. So that means what here? M inverse 1 L to the power of minus 3 T cube and A to the power of 2. That is the dimension formula of conductivity, and that is what unit is what? Ohm meter. That means what? Ohm inverse and meter inverse. That is the dimension formula of conductivity. And now coefficient of self-inductance. Coefficient of self-inductance or coefficient of mutual inductance. Formulas are like this. Here epsilon is equals to minus L into di by dt. Epsilon is equals to minus L into di by dt, or epsilon is equals to some minus m into di by dt. Here L is the self-inductance and m is the mutual inductance. So from that, what we did here, L is equals to epsilon into dt by di. We can write like this. Clear? What is epsilon? EMF. EMF is nothing but dimension formula of potential. V is equals to W by Q. So m L square T inverse 2 by A into T. Then what you get? V is equals to m L square T inverse 3 A inverse 1. So substitute here epsilon m L square T inverse 3 A inverse 1 of, here what it is? Dt, time t by current A. So then what is here? M L square T inverse 3 and it is t and to the power of minus 1. Then what is here? M L square T to the power of minus 3 minus plus 1 minus 2 and to the power of minus 2. So this is the dimension formula of self-inductance or mutual inductance. Same thing here. Clear? So and its units are Henry. We can show like capital H. Clear? So otherwise you can write unit like this also. From this formula we can write L is equals to epsilon into dt by di. What is epsilon here? EMF, volt second for ampere. Volt second for ampere also you can write. Let's see now some of the dimension formula of heat topics. Okay, the first thing is here heat is nothing but it is a form of energy. Clear? So for energy dimension formula is what? ml square T inverse 2. ml square T inverse 2 is the dimension formula of heat and the units are now joule. Next thing is specific heat. S is equals to 1 by m into dq by dt. Here dq is the heat energy. So m L square T inverse 2 by mass capital M, and dt is what here? Temperature. It is K. All I told you, temperature may be shown like K or theta. Clear? Then what are here? M to the power of 0 L square T inverse 2 and K inverse 1, or you can show like this also, simply m to the power of 0 L square T inverse 2 or theta inverse 1. Here K and theta represents the both here temperature. Now what are here? S is equals to 1 by m into dq by dt. So dq is what? Energy, joule for mass kg, and dt temperature, joule for kg Kelvin. That is unit for specific heat. And next thing here now, latent heat formula is what? Q is equals to m into L. Q is equals to m into L, that is the amount of heat energy, and from that L is equals to what? Right? Q by m we can write, Q by m, mass. So Q is what? Heat energy, m L square T inverse 2 by mass is what? Capital M. So then obviously what is here? M to the power of 0 L square T inverse 2, L square T inverse 2, that is the dimension formula of latent heat. So again this what, right? Joule for kg, joule for kg. Q by m, Q is the energy, joule, and mass is kg, joule for kg. And next thing here, coefficient of thermal conductivity. Times already formula as. So K is equals to Q into L by A into theta minus theta 1 into T. So here Q is the amount of heat energy supplied, and theta to theta 1 are what? Temperature difference between the two surfaces of a body, and A is the area and T is the time, and L is the length of the conductor, of heat. Clear? Here from the dot right, Q is what? Energy, ml square T inverse 2, ml square T inverse 2, and it is what? Here L, length, by area, L square, theta 2 minus theta 1, K, and now it is time, capital T. So then what did here? M, L for 0, M, L, T inverse 3, and K inverse 1, M, L, T inverse 3, K inverse 1, and you can write like this also, M, L, T inverse 3, theta inverse 1. Clear? So L square cancel, we have L only, M, L, T inverse 3 and K inverse 1 or theta inverse 1. So this one is joule for meter second Kelvin, joule for meter second Kelvin. So here what you know, P is equals to W by T, work for time. That means what? Joule for second also is what you call here watt. So we can write this also, joule for second, we can write by here S, joule for second is nothing but watt for meter Kelvin. That is also unit for now. Here coefficient of thermal conductivity. So joule meter second Kelvin or watt for meter Kelvin or watt meter inverse Kelvin inverse 1, we can write. Now let's discuss about the physical quantities which are having the same dimensional formulas. So if you can remember this one, then you will maybe save so much of time in your examination. సో మనకి ఏవైతే ఇప్పుడు డిస్కస్ చేయబోతున్నామో వాటిని మనం ఈజీగా గుర్తుంచుకోగలిగితే ఎగ్జామ్లో చాలా టైం సేవ్ అవుతుంది. ఓకే, లుక్ హియర్, quantities having same dimensions. So quantity and dimension formula. Look here, frequency, angular frequency, angular velocity, velocity gradient and decay constant all are having the same dimension formula, that is T inverse. Next, work, internal energy, potential energy, kinetic energy, torque and moment of force, they also have same dimension formula, that is m L square T inverse 2. Next, pressure, stress, Young's modulus, bulk modulus and modulus of rigidity or bulk modulus of rigidity and energy density. So all are having same dimension formula, m L inverse 1 T inverse 2. Next, momentum and impulse, both are having the same dimension formula, m L T inverse 1. And next, acceleration due to gravity, gravitational field intensity, so L T inverse 2. Next, thrust, force, weight, energy gradient, they have m L T inverse 2, same dimension formula. సో ఏవైతే మనకి ఫిజికల్ క్వాంటిటీస్ ఉన్నాయో అవి ఒకే విధమైన డైమెన్షన్ ఫార్ములా ఉన్న వాటిని మనం ఈజీగా ఐడెంటిఫై చేయగలిగితే, మైండ్లో ఉంచుకోగలిగితే మనము ఎగ్జామ్లో ఆన్సర్ సొల్యూషన్ చేయకుండా మనం ఆన్సర్ సెలెక్ట్ చేసుకునే అవకాశం ఉంటుంది. సిమిలర్లీ surface tension, surface energy, both are having same dimension formula, that is what, m L to power 0 T inverse 2. And this is the most important, you have to remember, all these are the dimensionless quantities. సో ఈ ఫిజికల్ క్వాంటిటీస్ మొత్తానికి డైమెన్షన్స్ ఉండవు, ఇది చాలా ఈజీ గుర్తుపెట్టుకోండి. స్ట్రెయిన్, రిఫ్రాక్టివ్ ఇండెక్స్, రిలేటివ్ డెన్సిటీ, యాంగిల్, సాలిడ్ యాంగిల్, డిస్టెన్స్ గ్రేడియంట్, రిలేటివ్ పర్మిటివిటీ, రిలేటివ్ పర్మియబిలిటీ అండ్ పాయిజన్స్ రేషియో, all these are the dimensionless quantities. That's why here dimension formula is m to the power of 0, L to the power of 0, T to the power of 0. And now latent heat, gravitational potential, both are having the same dimension formula, m to the power of 0, L square T to the power of minus 2. And thermal capacity, Boltzmann constant, and entropy, these three are having the same dimension formula, m L square T inverse 2 theta inverse 1, or m L square T inverse 2 K inverse 1. Clear? And now under root of L by G, under root of m by K, under root of R by G, these are the equations. L is the length, G is the acceleration due to gravity, and m is the mass, and K is the spring constant, and R is the radius of the earth. So these all having same dimension formula, that is m to the power of 0, L to the power of 0, T to the power of 1. Clear? Here L by R, root LC, RC, where L is the inductance, R is the resistance, and C is the capacitance. While we have this type of formula, then the dimension formula is m to the power of 0, L to the power of 0, T to the power of 1. And similarly here, when we are finding any equations in the question like this, you have to observe this one. I square RT, V square by R into T, VIT, QV, and Li square Q square by C, where Q is the charge, C is the capacitance, I is the current, L is the inductance, and T is the time, and R is the resistance. So all are having the same dimension formula, that is like m L square T inverse 2. Okay, clear? Now let's discuss some type of model questions. Which type of questions are going to be asked in the examinations? So let's go for that. If G is the acceleration due to gravity and R is the radius of the earth, if G is the acceleration due to gravity and R is the radius of the earth, then the dimension formula for GR is, options are given, m L square T inverse 2, and m to the power of 0 L square T inverse 2, and m to the power of 0 L to the power of 0 T square, and m to the power of 0 L to the power of 0 T to the power of 0. So what was given? R G ఏమన్నాడు, యాక్సలరేషన్ డ్యూ టు గ్రావిటీ అనుకున్నాడు, R నేమో రేడియస్ అనుకోమన్నాడు. అప్పుడు GR యొక్క డైమెన్షన్ ఫార్ములా ఏమవుతుంది అంటున్నాడు. సో వాట్ ఈస్ G? యాక్సలరేషన్ డ్యూ టు గ్రావిటీ, that is quite similar to the dimension formula of acceleration, that is what L T inverse 2. And what he was given, R ఏమన్నాడు, radius is nothing but length, that's what it is dimension formula L. Therefore GR is equals to L T inverse 2 and L. So here what do you write? L and it is what? T inverse 2. So when base are equal, we have to add the exponents. Clear? Base equal అప్పుడు మన exponents ని యాడ్ చేయాలి. అప్పుడు ఏమవుతుంది? L square T inverse 2. సో దీన్ని మనం రాసుకోవచ్చు అంటే we can write like this, m to the power of 0 L square and T inverse 2. Clear? That's why option 2 is the right one. See the next question. If m is the mass and k is the force, m is the mass and k is the force per unit length, what is the dimensional formula for m by k? Options are given, m to the power of 0 L to the power of 0 T to the power of 0, and m to the power of 0 L square T to the power of 0, m to the power of 0 L to the power of 0 T square, m square L to the power of 0 T to the power of 0. So what he was given, m is mass, k is the force per unit length, okay. So m is what? Mass. Its dimension formula is what? Capital M. And what he was given, k is equals to force per unit length. So that means what here? M L T inverse 2 by length L. Then what you get here, it is M T inverse 2, MT inverse 2. Clear? Now what you have to find out? Dimension formula of M divided by K. So M means what? It is dimension formula capital M, and K is what? MT inverse 2, MT inverse 2. Then what you get here? M to the power of 1 and m to the power of minus 1 and T square. Then what it is? M to the power of 1 minus 1 T square. That means what? M to the power of 0 and T square. So simply what it here? It should be written as m to the power of 0 L to the power of 0 and T square. So this is the dimension formula. That's why here third option is the right one. See the next question. This is the different type of model. The dimension formula for the angular momentum is same as that for The dimension formula for the angular momentum is same as that for Planck's constant, impulse, torque and gravitational constant. So angular momentum యొక్క డైమెన్షన్ ఫార్ములా అనేది ఈ క్రింది వాటిలో దీని యొక్క డైమెన్షన్ ఫార్ములాతో ఈక్వల్ అవుతుంది అంటున్నాడు. ఓకేనా? సో ఫస్ట్ మనకి angular momentum dimension formula తెలిసి ఉండాలి. To answer this question you must know about the dimension formula of angular momentum. So what is the formula here? L is equals to mvr. So m is the mass, v is the velocity, L d inverse 1 and r is the distance. Then what it is? ml square t inverse 1. So this is the dimension formula of angular momentum. Okay, now let's check how many there. Gravitational constant F is equals to g into m1 m2 by r square. Then g is equals to what? F into r square by m1 m2. Already we discussed. What is here? F is force, ml t inverse 2 and l r means l square by m square. Then what you get here? M inverse 1 L cube T inverse 2. That's why here both are not same. That's why fourth option is the wrong one. Next, torque. Tau is equals to R cross F. Torque is equals to R cross F. ML T inverse 2 into L. Clear? Then what you get? ML square T inverse 2. So these two are not same. That's why third option also wrong. And now impulse is equals to force into distance. So ml t inverse 2 into force into time. Then what you get here? ml t inverse 1. So both are not same. That's why second option also wrong one. Now Planck's constant, finally that is the right one. E is equals to h nu. Then h is equals to what? E by nu. What is E? Energy. ml square t inverse 2 by t inverse 1. Then ml square t inverse 2 t. Then what you get? ml square t inverse 1. That's why Planck's constant and angular momentum both are having same dimension formula. That is what? ml square t inverse 1. So option 1 is the right answer. See the some more questions. First question is there here. The dimension formula for the time rate of change of impulse. Rate of change of impulse is same that for. So here rate of change of impulse. Rate of change of impulse యొక్క dimension formula అనేది ఈ నాలుగిట్లో దేని ఈక్వల్ అంటున్నాడు? ఫోర్స్, ఇంపల్స్, పవర్ ఆర్ ఎనర్జీ. సో హియర్ already we know that what it is impulse. Impulse is equals to F into T. Clear? Then rate of F into T means what? Then what you get here? F into dt by dt we will get. Then one is what? It is F, force. So that's why force dimension formula is that of rate of change of impulse. The first option is the right one. And see the next question. The dimension formula for strain is same that of. The dimension formula for strain is same as that of as it for stress, modulus of velocity, thus angle of twist. So already we know that what it is. Strain is the dimensionless quantity because change in dimension per original dimension. That's why here it is a dimensionless quantity. M to the power of 0, L to the power of 0, T to the power of 0. Now here stress is that what it is. Stress is equals to force per area, and modulus of velocity also having the same dimension formula of stress. So m l t inverse 2 by l square. That means what? M l inverse 1 t inverse 2. Clear? So m l inverse 1 t inverse 2. That's why these two are not same. That's why these two are wrong options. And thrust is nothing but force. M l t inverse 2. So these two are not same. That's why this also wrong option. So now angle is the angle of twist. Angle is the what, right? Angle is equals to arc by radius. It is the dimensionless quantity. That's why here fourth option is the right one. The dimension formula of strain should be same as that of angle of twist. Next, the dimension of angular frequency. The dimensions of angular frequency are the same that for angular frequency డైమెన్షన్ ఫార్మ్ అనేది వీటిలో ఏ దేనికి ఈక్వల్ అంటున్నాడు. ఇట్ ఈస్ ఫ్రీక్వెన్సీ, టైం పీరియడ్, యాంగిల్ ఆర్ యాంగిల్ బై ఫ్రీక్వెన్సీ. క్లియర్. సో ఆల్రెడీ వీ నో దట్ time period is formed what it is. T is equals to 2 pi by omega. Then omega is equals to what? 2 pi by t we can write. Nothing but here omega is equals to 1 by t. That is equals to what? T inverse 1. T inverse 1. So T inverse 1 is nothing but dimension formula of frequency. Dimension formula of frequency. That's why here angular frequency and frequency both are having the same dimensional formula. Clear? So dear students and viewers and aspirants, if you can understand the content what I was explaining in this video, like, share, comment the video. So if you can feel it is very useful, then please do a help for me, share this my channel to the required people. ఎవరికైతే మన ఛానల్ అవసరం ఉంటుందో వాళ్ళకి మన ఛానల్ షేర్ చేయండి, సబ్స్క్రైబ్ చేసుకొని చెప్పండి, ఖచ్చితంగా హెల్ప్ అవుతుంది, నా ఛానల్ కూడా సపోర్ట్గా ఉంటుంది. ఓకేనా? థ్యాంక్ యూ ఫర్ వాచింగ్.